All right, hey AP Physics students, and welcome to this video lecture, as promised by yours truly, Mr. Welch. This video is going to cover acceleration. So to begin, just like with anything that we've done, that we've learned so far, whether it was distance, displacement, speed, or velocity, we need to have a verbal definition for acceleration. And that verbal definition is, first and foremost, that acceleration is a vector quantity. So we need a magnitude and a direction with acceleration. And it is defined as the rate at which an object changes its velocity. So it should make sense that acceleration is a vector quantity because it's based on the change in velocity, and we know that velocity is a vector quantity. So an object is accelerating if it's changing its velocity in any way. Now, going along with our verbal definition, we need a mathematical definition for acceleration. So our mathematical definition is going to be acceleration is equal to our change in velocity divided by time. Okay, anytime we have a quantity divided by time, that's giving us a rate. Okay, so when we say rate, that's something divided by time. Now we can extend this mathematical definition out even further, and we can say that acceleration is equal to our velocity final minus velocity initial over time. Now, another really important thing that we need to know for acceleration is the units that we use for acceleration. So I'm going to rewrite our equation down here. Acceleration is equal to change in velocity divided by time. And let's just take our standard velocity units that we're going to be using in this class. We'll take meters per second, and then time, we also have seconds. So we want to get units for acceleration. And what we're going to be doing then is we want to get rid of this seconds in the denominator here. So what we have to do then is multiply our denominator by 1 over seconds, and then we're going to multiply our numerator by 1 over seconds. And what that is going to give us is meters per second per second. And anything multiplied by itself is going to be squared, so our units for acceleration are going to be meters per second squared. Okay? Now there's two types of acceleration that we can have moving towards the bottom of this page here. The first is going to be constant acceleration. And the word constant should trip something in your brain here, that this is saying that velocity is changing by a constant amount each second. So an example, if I dropped a ball from some height, it's going to increase its velocity by 9.8 meters per second each second. Okay, so for every second, that ball is going to be increasing its velocity by 9.8 meters per second. Now, conversely, we have non-constant acceleration, which is velocity is changing by a different amount each second. So that should be pretty self-explanatory for you. So this first slide here is just our introduction into the definition, both verbal and mathematical, and the two types of acceleration that we can have. But primarily, for our purposes, we're mostly going to be dealing with a constant acceleration in the problems that we work with. All right, so a very important thing to note with acceleration is that it is a vector. And prior to this, when we're thinking about vectors in terms of displacement and velocity, things have been pretty straightforward in terms of whether it's positive or negative. Okay, our convention, again, is that our positive direction is typically to the right or up, and then negative is to the left or down. All right. Now, the direction of the acceleration vector actually depends on two things. First, we have to find out or figure out whether the object is speeding up or slowing down. And then also, along with that, we need to determine whether the object is moving in the positive or negative direction. So our rule of thumb, to kind of summarize these two, is that we're going to say if an object is slowing down, then its acceleration is in the opposite direction of its motion. Okay, so if an object is slowing down, then its acceleration is in the opposite direction of its motion. So to give you an idea of how we determine the direction of the acceleration, I want to go through a few examples here. So first, let's take a look at example A. We can see that our velocities in this column are positive, so that needs to trip us off that we're actually moving in the positive direction. Okay, so that's going to tell us then that our velocity is positive. And then if we take a look here at how our velocity is changing, we can see that it has a constant positive increase. So because we're speeding up and it's in the positive direction, we know that our acceleration is also positive. Oh, I'm going to run out of room here. There we go. All right, now moving on to our next sample, we see that our velocity values are actually negative. Okay, so that needs to trip us off that we are moving in the negative direction. So we're moving in the negative direction. And if we're moving in the negative direction, well, that tips us off that we have a negative velocity. And we are slowing down because you can see that our velocities are getting smaller and smaller and smaller and smaller until we get to zero. So that means we're slowing down. But now here's where this becomes a little bit tricky. We're moving in the negative direction. We have a negative velocity, but we're slowing down. So if we're slowing down, the acceleration is actually in the opposite direction of the motion of that object. So what that means is that we actually have, again in this example, a positive acceleration. Okay, so we're moving in the negative direction, but we are slowing down in the negative direction. So that means that our acceleration is opposite of its motion, therefore the acceleration is positive. Now a couple more examples here. If we take a look at our first set of data, example C, we see that our velocity values are positive. So that trips us off that we are moving in the positive direction. So we're moving in the positive direction, but what's happening with our velocities here? What's happening with our velocities here? We're actually slowing down. Okay, our velocities are slowing down. So, because we're moving in the positive direction, we know that we have a positive velocity. However, as I said, we are actually slowing down here because our velocity values are decreasing. So if we're slowing down, our acceleration is in the opposite direction of its motion. So in this case then, we have a negative acceleration. Okay? And now in our last example here, example D, taking a look at our velocity values. Well, we have negative values there, so that trips us off that we're moving in the negative direction. Okay, we're moving in the negative direction. So again, if we're moving in the negative direction, we have a negative velocity. But now, what's happening with our velocity values? They're actually increasing in the negative direction. So we're actually speeding up in the negative direction. So if we're speeding up in the negative direction, our acceleration is still going in the direction of this object's motion. So in this case, we have a negative acceleration. Okay, so keys here when determining the direction of the acceleration. Really focus on that rule of thumb. If an object is slowing down, then its acceleration is in the opposite direction of its motion.